Alright guys, this is unit number 9, lesson 2, and today you're going to learn about irrational numbers. And basically what it is all the real numbers, the numbers that you know, are broken up into two distinct different types of numbers. There's rational numbers and irrational numbers. So every number that you could think of or see is either rational or irrational. It can't be both. So here's some definitions of rational and irrational. First, a rational number is any number that can be written as a ratio of two integers. Basically what this is saying is a fraction. Ratio between two integers. So I have some examples up here, 3/4 and 1/3. Both of those are ratios or fractions, and these are rational numbers. Here's some more rational numbers. And when you convert any rational number, any fraction, it's going to be two different types of decimals. It's going to be terminating, which means ends, or repeating decimal. So for instance, 3/4 you should know is 0.75. Slide this out of the way here. Make it, put it, I don't know, over there. So you can see that this is a terminating decimal. It stops. There's no more things after 5. And you should know 1/3 is actually the decimal that goes like this, 0.3, and it just goes on forever. And we represent that by saying 0.3 with a little line over it. So that's a repeating decimal because it's repeating the same thing over and again. And you could have patterns like, I don't know, you could have a rational number that's like 315, 315. That's supposed to be a 5. That's still a pattern because you can see it in there. So it doesn't have to be the same number repeating. You just have to be able to find the pattern repeating over and over again. So remember, terminating means it stops. Repeating means there's some pattern that's repeating over and over again. So those are rational numbers. And the big thing is, could it be written as a fraction? That's it. Rational numbers can be represented by fractions. Irrational numbers, therefore, are just the opposite. They're not rational, so they cannot be written as a fraction. And therefore, the opposite is that they're non-terminating, non-repeating decimals. And if you think about pi, hopefully you know some things about pi, is that it's endless amount of decimal places, and there's never a pattern repeated. It's completely random. So if you think of irrational, think of pi, because it's really hard to imagine how many decimal places pi has. It goes on forever, but it's still less than 3.2. So it's kind of weird to think about. That's why we call it irrational. So hopefully by the end of this lesson, you'll understand really what irrational numbers are. So we'll go through some exercises to help you understand that. So let's consider the rational number that is irrational, and one that's irrational. So we have 2/3, it's written as a fraction, and we have the square root of 1/2. This is an irrational number, we'll show you. Both of these are less than 1. So we want you to draw a picture to represent 2/3 using this little rectangle. I think they called that a tape diagram, so maybe if you remember your 5th or 6th grade, you did tape diagrams. So draw a picture using this rectangle to represent 2/3. So do that now, please. Hit pause and try that. Alright, hopefully you got something like this. And you can see that that's 2/3 because we broke the rectangle into 3 parts, and we have 2 of them. So that's 2/3. Using your calculator, give the decimal representation of 2/3 now. Notice that it's a repeating decimal. So go ahead and put that in your fraction, or put that in your calculator and see what you get. Alright, so you should have got something like that, 0.6 repeating. So remember we said that all rational numbers are going to be a repeating decimal or terminating decimal. Okay, we'll keep going here. Alright, now write out all the decimal places your calculator gives you for, look, this is the square root of 1/2, so you need to put that in your calculator correctly, so be careful. Make sure that 1/2 is completely under the square root symbol. And so hit pause and give that a try, see what you do. Okay, hopefully your calculator gave you this. And the thing is, your calculator won't go on indefinitely, so it just chops it off at one point. But notice that none of these are repeating. You can't see a pattern that's repeating over and over again. And if we kept going, this would just keep randomly going, and there would be never a pattern in the decimals, and this would end up looking like pi. Not exactly like pi, but the same concept, where it'd just be decimals after decimals after decimals, and nothing would repeat. Alright, so why could we not draw a pictorial representation of this? So why couldn't we draw, just like we did over here when we drew that rectangle, why would we not be able to do it for the square root of 1/2? Well, think about the definition of the square root of 1/2. And it comes down like this. I guess I'll just get rid of it all. Why not? So it says, since the square root of 1/2 is an irrational number, it can't be written as a fraction. That's important. And therefore, it can't be divided into subparts. So when we say 2/3, we divided something into thirds and then took 2 of them. Well, if irrational numbers can't be fractions, it can't be broken down into little subparts. All right, so let's keep moving on. This is kind of some stuff. We'll read through it, but whoops, that's not what I wanted. Here we go. Irrational numbers are necessary for a variety of reasons. We'll use them quite a bit, but they are somewhat of a mystery. In essence, they are numbers that can never be found by subdividing an integer into a whole amount. It's kind of what we talked about, of parts. Then taking that integer number of those parts. I know it's kind of hard to understand. Don't worry so much about that. There are many, many types of irrational numbers. Think of pi, that's the most popular one. Also, every square root of a non-perfect square is always irrational. So if it's not a perfect square and you try to take the square root of it, it's going to be an irrational number. So we'll give you some examples here. Write out every decimal your calculator gives you for these irrational numbers. Notice that none of these are perfect squares. You can't take the square root of 2, can't take the square root of 10, and can't take the square root of 23. So go ahead and hit pause and just put them in your calculator really quick. All right, you should have gotten something like these numbers, and notice that there's no repeats. I know you might think, well, look, this is 6, 6 repeating. If you keep going, no, it's not. And you can't see there's a pattern of 2, 7, 6. That's still random right there. And this is also random. So you can see these are all coming out to be irrational numbers. So any non-perfect square will be irrational. Just remember that. All right, we're going to keep working on. Rational and irrational numbers often mix, and then we simplify the square root of non-perfect squares. So consider the irrational number, the square root of 28. Without using your calculator, between what 2 consecutive integers will this number lie? So between what 2 numbers is this, since we know this is going to be a decimal? Think about what 2 numbers this would be. Could you guess? Hit pause and figure that out. Were you able to come up with 5 and 6? Because if you think about it, the square root of 25 is 5, and the square root of 36 is 6, and 28 is somewhere between the square root of 28 and the square root of 36. So we know this number is going to be 5 point something, because it can't be 5, because the square root of 25 is 5. This can't be 6, the square root of 36 is 6, so it's in between those somehow. Now go ahead and use your calculator, plug it in and see what you get. All right, were we right? Yes. And you can see that 28 is closer to 25 than 36, so that's why it's like 5.3, not 5.8. Okay, now a little bit of review from last. Can you simplify this? So it's very important. Make sure you hit pause and do this on your own. So simplify this in radical form. So you're reducing the radical. Do that now, please. All right, hopefully you came up with 2 radical 7, because 28 is 4 times 7, and the square root of 4 is just 2. Now we want you to write out the decimal form of this. So put this, 2 radical 7, in your calculator. So make sure you can write that correctly. Hit enter and see what you get. And hopefully it was the exact same thing, because the square root of 28 is the exact same as this. So I just wanted to show you that this number has the same value as this number, just written in different forms. All right, we'll keep going here. All right, so it appears that non-zero rational numbers times an irrational number, CC, result in an irrational number. We would also investigate what happens when we add rational numbers. So, for each of the following addition or subtraction problems, a rational number has been added to an irrational number. Write out the decimal representation that your calculator gives you and classify it as rational or irrational. So do the math here in your calculator. Write out the decimals and tell us if it's rational or irrational for each of these. So do that now, please. All right, you should have gotten here, here, and here. And all these came out to be irrational numbers. Because think about, this is going to be irrational. When you add it to a rational, you're still going to have all those decimals. They're not going to go away. So when you have an irrational number and you add it to a rational, it looks like it's always coming out to be irrational. And that's what we're going to say down here. I thought maybe it's the next part. Alright, so here's what I was looking for. Basically, fill out the following statement about the sum of rational and irrational numbers. When a rational number is added to an irrational number, the result is always irrational. Alright, and last part, this should be easy. Which of the following is an irrational number? If necessary, play around with them and we'll see how it comes out. So, so determine which one of these are irrational. So hit pause and try that now. Alright, how did you do? So number 1, the square root of 25 is actually the number 5, which could be written as a fraction as 1 over 5, or 5 could also be a terminating decimal, where you have a 0 here, or it's actually a repeating decimal because it's just 0, 0, 0. So number 5 fits every definition, number 1 fits every definition of a rational number. Number 3 is obviously rational because it's written as a fraction, and that's the definition of a rational number. It could be expressed as a ratio. Number 2 might look irrational, but just do the math. So this is 4. The square root of 9 is 3, so this is really 4 minus 3, which is 1, which is the number 1 over 1, or 1.0, so again that is rational. This number here, you cannot take the square root of 6. You get some big long decimal. So that one right there, since that is not a perfect square, and I take a rational number and add it to an irrational, I know this is going to be irrational. So you should have got number 4. Alright, that's it. We'll practice these in class, and hopefully we'll take a little time to make sure you understand everything that was represented in this lesson.